So let us go straight to the Agulhas current. It's a western boundary current. It's a relatively narrow stream flow, with speeds exceeding meters per second. And it does something very similar to the East Madagascar current. So what it does is it becomes retroflected. Okay, it turns the direction and then moves to the east. Okay, and it also produces mesoscale eddies. Okay, and the formation of these eddies is shown here in this little sketch. You have the sharp turn of the currents, and then their interaction, and it creates the shedding of eddies, mesoscale eddies, that become detached and then move over into in this case, the Atlantic Ocean. So now here it comes. These eddies are actually an important part of the return circulation of the deep circulation of the ocean. So in case you're surprised, you talked about the deep circulation, and there's this movement of deep water from the North Atlantic through the Indian Ocean into the North Pacific. These regions where these eddies are formed are actually part of the return flow near the surface. Okay, these areas. And they're extremely complicated to study. Here are some maps, some early maps of illustrating the eddies. I told you before that you can actually reconstruct eddies from measurements of temperature and salinity, and you can reconstruct the horizontal currents associated with that. And also shown here are some early drifter and satellite observations on them. Okay. So now the Agulhas current creates upwelling in interaction with a shallow water region known as the Agulhas Bank, which stretches along the southern coastline of South Africa. Okay, so we have a look at that upwelling. Okay. So on the next one, it shows you very, very old satellite observations from very, very old. You can see South Africa here, the coastline, and dark is warm water, and the brighter water is actually upwelled water. And you can see the numbers tell you the temperature. And this is actually upwelling. I show you on the next slide is a more recent. Okay, but this is always important to try to get a passion for the early discoveries. How did these people actually discover upwelling in the absence of either without any satellites, just being on a boat doing measurements from these rare measurements. Again, in the top shows you a little bit here the distance from the coast, temperature fairly low on the Agulhas Bank, which is again a signature of up. Okay, in these relatively warm regions, if you have cold water appearing at the surface, it must be the upwelling of subsurface water. And this is all to do with your understanding of the stratification in these areas. Okay, because it's the temperature that controls the stratification. So the warmest water is near the surface. Okay, and then if you have upwelling, you actually lift colder water to the surface, and you can see it at the sea surface. And then it clicks in. You immediately affiliate the upwelling of nutrient-enriched water and the potential to create algae blooms. And let's have a look at the more recent satellite observations. This again is chlorophyll A concentration here on the right. On the left shows you the bathymetry of the Agulhas Bank. You can see it's 100 meters shallow shelf region. Okay, the blue is 4,000 or 5,000 meters. And you can see this is the shelf edge. Okay, the shelf break, 100 meters. And on the right-hand side, you can essentially see the so-called filaments, we call them. Okay, you can see regions of enhanced productivity. Also shown here is the Benguela current coastal upwelling system, which will be discussed as part of the Atlantic Ocean lectures. So this is the connection to the Atlantic Ocean, but you can also see these regions here on the Oculus bank. Indeed, and it has a highly productive ecosystem there, with quite a yield from the fisheries. Okay, so this is upwelling over the Oculus. Now let's have a look to the last of the boundary currents, which is actually a boundary current that exists off the west coast of Australia.